In this lecture, we will discuss the logic gates. So let us first try to know what are logic gates. The logic gates are the basic building blocks of any digital system. It is impossible to build any digital system without logic gates. So a logic gate is an electronic circuit having one or more than one input, but it has only one output. And the relationship between the input and the output is based on certain logic. That is, the relationship between the input and the output is based on certain logic for all the logic gates. So based on this logic, there are 7 types of logic gates, and each gate has a different logic. That is why these gates are called logic gates, because these gates work on logic. There are 7 types of logic gates. These are the AND gate, the OR gate, third gate is the NOT gate, the fourth gate is the NAND gate, the fifth one is the NOR gate, the sixth gate can be written as EXOR, that is XOR, or it can also be written as XOR, and the full form of this gate is exclusive OR gate. And the last gate is the exclusive NOR gate, which can be written as EXNOR or XNOR. So these are the 7 types of logic gates. Now let us discuss all these gates one by one. The first gate is the AND gate. Now what is an AND gate? An AND gate is a circuit which will have 2 or more than 2 inputs, but it will have only one output. So we can say that an AND gate is a circuit which has n number of inputs, where the value of n can be either equal to 2 or more than 2, but it will have only one output. And it is a circuit which performs AND operation, and AND operation actually means multiplication operation. So the output in case of AND gate will be obtained by multiplication of all of its inputs. So if y is the output of the AND gate, and if a, b, c up to n are the inputs of the AND gate, then the output will be obtained by the AND operation of all the inputs. So we can write that y is equal to a and b and c and d up to n, because we know that an AND gate performs AND operation of the inputs. So y is equal to a and b and c and d and up to n, and AND operation is actually multiplication operation. So this can be written as y is equal to a dot b dot c up to n, or simply y can be written as a b c up to n. In this case, y is the output of the AND gate, and a, b, c up to n are the inputs of the AND gate. Now we will try to draw the symbol of the AND gate. So as you can see in this figure 1, this is the symbol of AND gate, that is AND gate is represented by this symbol. So if we want to draw the logic symbol of 2 input AND gate, then we will consider only 2 inputs and there is a single output in AND gate. So this is the logic symbol of 2 input AND gate. That is, in 2 input AND gate there will be 2 inputs which has been denoted by A and B, and there will be only one output which has been denoted by Y. And if we want to write the logic formula of the 2 input AND gate, then the logic formula will be y is equal to a dot b. That is, in AND gate just multiplies the inputs. So the logic formula of the 2 input AND gate will be y is equal to a dot b. So this is the logic formula of 2 input AND gate, and this is the logic symbol or logic diagram of 2 input AND gate. Similarly, if we want to draw the logic symbol of 3 input AND gate, then we will consider three inputs which we have named as A, B and C, and we know that there is only one output, so output has been denoted by Y. So this is the logic symbol of 3 input AND gate, and the logic formula of the 3 input AND gate will be Y is equal to A dot B dot C, which has been written here. Similarly, if we want to draw the logic symbol of n input AND gate, then we will consider an AND gate having n number of inputs, which has been denoted by A, B, C up to n. And since AND gate has only one output, so the output has been shown here by Y. So this is the logic symbol or logic diagram of n input AND gate, and the logic formula of the n input AND gate will be obtained by multiplying all these inputs. So the output Y will be equal to A dot B dot C dot dot up to n. So this is the logic formula of n input AND gate. Now let us draw the truth table of the 2 input AND gate. So what is a truth table? Truth table is nothing but it is a table which will show the relationship between the input and the output variables. So we will draw 2 columns showing the input and the outputs, and since this is a 2 input AND gate, so there will be 2 inputs A and B. Under the column input there will be 2 inputs, and since there is a single output, so we have drawn only one column here. So this is the output Y, and these are the inputs A, B for 2 input AND gate. Now the inputs A and B can have only 2 values because logic gates work on binary. So the value of A can be either 0 or 1. So the first possibility is that both the inputs A and B are 0. The second possibility is that the value of the input A is taken as 0 and the value of the input B is taken as 1. Similarly, the third possibility is if we take the value of A as 1 and B as 0, and the fourth possibility is when both the values of the inputs are high, that is when A is also 1 and B is also 1. So the value of Y will be obtained by the multiplication of these inputs. So when 0 is multiplied by 0, we get a 0. When 0 is multiplied by 1, we get again 0. When 1 is multiplied by 0, we again get 0. And when 1 is multiplied by 1, we get 1. So this is the truth table of 2 input AND gate. From this truth table, we find that the output is high only when all the inputs are high, or we can say that the value of the output will be 1 only when all the inputs are 1. Similarly, we can draw the truth table of 3 input AND gate. In a similar manner, we can draw the truth table of 3 input AND gate, and in case of 3 input AND gate also we will find that the output of the AND gate will always be 1 only when all the values of the inputs are 1. So this is the truth table of 2 input AND gate. Hope you have understood what is a logic gate and how we can draw the logic diagram or logic symbol of AND gate, what will be its logic formula, and how to write the truth table of 2 input and 3 input AND gate. In next lecture, we will be discussing the remaining gates, that is the OR gate, the NOT gate, and NAND gate, NOR gate, XOR gate and XNOR gate.